Today we're going to look at section 2 of chapter 6. In that first section that we finished up, we were working with any kind of polygon, and we learned information about interior and exterior angles. The rest of this unit is going to focus on different types of quadrilaterals. So in this second section of chapter 6, we are going to be talking about properties of parallelograms. And then once we learn about those properties, we're going to be able to work with their sides, their angles, and their diagonals to be able to work through some problems, and we'll look at some examples. So when you open up that parallelogram flap in your notes, you have a place to fill in these properties of parallelograms. So I'll give you a minute to get those written down, and then we will talk about them. Taking a look at these properties, the first one tells us that opposite sides are parallel. That comes directly from the definition of a parallelogram. A parallelogram is a quadrilateral where both pairs of opposite sides are parallel. First semester, we had a whole unit on parallel lines cut by transversals. So that's where some of this other information comes from, is by applying what we learned about parallel lines cut by transversals. So it gives us lots of information. Another property of parallelograms, along with the opposite sides being parallel, the opposite sides are also congruent. They have the same measure. So that's going to be helpful as we work through problems. Along with the opposite sides being congruent, opposite angles are also congruent. Consecutive angles are supplementary. Okay? And this idea of consecutive angles, when you see a picture of a parallelogram here in a minute when we look at some examples, those consecutive angles are what we had as same side interior angles when we worked with our parallel unit. So that's where they came up with this property that the consecutive angles are supplementary. Because if we thought about the parallel lines and a transversal, those angles are same side interior angles. And then the last thing has to do with the diagonals. So if we cut through from a vertex to the opposite vertex and draw in diagonals, those diagonals bisect each other. They cut each other into two equal parts. So one angle or diagonal is bisecting the other one. Okay, so not all of the parts are equal. The one diagonal has been cut into two equal parts. So we're going to be working with these properties to be able to solve some problems. So we have three examples that we're going to do. The first two examples in your book doesn't have a picture. So I would draw a picture so that you can label that information. So you have that visual. Otherwise, just by looking at the words, it makes it hard to know what it is that we're looking at. Okay. In this first example, you would not need to draw the diagonals in because we aren't using the diagonals. Okay. But I would encourage you to draw a parallelogram. It says if ABCD is a parallelogram, so when we name that shape, that quadrilateral, I can start at any vertex I want. It does not matter. I'm just going to start at the upper left-hand corner. I can go clockwise or counterclockwise, and I have to go in order. So I can't skip around. So I have my parallelogram ABCD. It tells me that angle A has a measure of X, and it tells me that angle D has a measure of 2x minus 3, and I want to find the value of x. So looking at my diagram and looking at those properties that we just talked about, what kind of a relationship do I know about angle A and angle D?
They're not opposite angles.
They're not opposite angles.
They're same side exterior. Right?
They would be same side interior if we were looking at our parallel lines cut by a transversal. So when we're talking about parallelograms and those properties, those are consecutive angles. Consecutive means one right after the other. Okay? So it's kind of like adjacent, only when we talked about adjacent angles, they shared a vertex. Okay? They're consecutive because one comes right after the other. They're next to each other. So that's what it means to be consecutive.
Does that mean they could move that?
So consecutive angles, what does our note say they are?
Supplementary.
They are supplementary, which means
3x minus 3 equals what we want.
so x plus 2x minus 3 equals 180. So I combine my like terms. My marker went crazy there. So I'm going to add 3 and then divide by 3. So I find that x is equal to 61. So by drawing that out, using my properties, I knew that angle A and angle D were consecutive angles, and I know consecutive angles are supplementary. They add up to equal 180. Example 2, again, I would encourage you to draw in a parallelogram. This time we are going to be working with the diagonals. So when you draw your picture, go ahead and draw in those diagonals. So this parallelogram is named X, Y, Z, W. So again, it doesn't matter where you start, clockwise or counterclockwise, you can't just jump around. So we have those, this parallelogram, and we have the two diagonals. So we have diagonal XZ, and we have diagonal WY, and they intersect at point A. So here in the center where they cross, that is point A. Then they tell me that XA, so from the vertex to that point A, is 3M. And they tell me that ZA is 5M minus 4. And I want to find M. So when I look at my properties for parallelograms, what do I know about this yellow piece and the green piece? They are equal to each other because this other diagonal bisected it, cut it into two equal parts. So I know that 3M is equal to 5M minus 4. So then I need my variables on one side. So if I subtract 5M, I get negative 2M equals negative 4. And then I divide and find that M is equal to 2. So I was using my property that dealt with the diagonals to come up with my equation. This last example, you have the picture in your notes. Okay. So we've got that parallelogram again. This time there are 3 different angles that we need to find, X, Y, and Z. Any idea on any one? It doesn't matter which one we might know.
Z is opposite of 120.
Okay. We have Z that is opposite of 120, and we know that opposite angles are congruent. So Z is 120. Trevor.
Figure out X by taking 120 plus 35 and subtract that from 28.
Okay, so he was finding X. Okay. If we look at the blue angles, okay, the blue angle is consecutive to 120, which means it would be 60. They are supplementary. If we take away that 35, then X is 25. And then we have Y, Caleb?
Alternate interior.
Okay. For Y is alternate interior with which one?
Y and 35 degrees. So
Okay.
equal.
The Y and 35. If we think of our parallel lines cut by a transversal, we have alternate interior angles, which are congruent. So we were using a variety of those properties to help us find those missing pieces. So those are the properties of parallelograms that we will be using.
Oh, I'm doing them all at once.
All of these pages?
Yeah.
Oh, no.
Last year in Carol's, we did like 4 of them in one day,
No,
and that was nuts.
no.